Okay, number 3, again, we're going to go ahead and label. So BD and CF are perpendicular. I want to prove the whole triangle is isosceles. So this ACF, I want to prove the whole thing is isosceles. So I'm going to label right angles. And then GE and CF. And then CE on the bottom. Again, I'm using my brackets because that's a whole length. And then DF. And then BC is congruent to GF. Okay, again, I want to prove the whole triangle is isosceles. So I want to prove AC and AF are congruent. So I'm just going to write that. AC is congruent to AF. So if I know that those two sides are congruent, I would know this whole triangle is isosceles. Okay, so before I do that, I want to prove these outside triangles are congruent. So again, to save us time, we're just going to write our given. And again, normally you would write all of these statements again in your given. Okay, so being perpendicular, I need to explain that I have right angles and that those angles are congruent. Okay, so I'm going to say angle BDC and angle GEF are right angles. So if is going to be, we have perpendicular lines. So if two lines are perpendicular, then they form right angles. Okay, again, when we do our proofs, we want our angles to be congruent to each other. So if we know that they're right angles, we know that they're going to be 90 degrees, which makes them equal. So angle BDC is congruent to angle GEF. If is what we have. So if two angles are right angles, then they are congruent. These two steps will always happen if you have perpendicular lines. So right angles, and then tell me that those angles are congruent. Okay, these two lengths being equal, those we don't need to say anything else about. Okay, so notice in my triangle, I have an angle and a side. So I'm missing my third piece. So I know that this big total is congruent to this total. Notice that they both share DE, so that is reflexive. So I'm going to say DE is congruent to DE, and that is reflexive property. Okay, and again, I want this little piece here. So if I have the total and I'm going backwards, that's going to be my subtraction. So again, I am taking this total, subtracting the reflexive part, and that's going to leave me these pieces here. So I'm going to say CD is congruent to FE. Again, this is my if-then subtraction. So if two congruent segments, which are my totals, are subtracted from a congruent segment, which is the reflexive piece. If I'm subtracting, I'm talking about the difference. Then the differences are congruent. Okay, so if I look now, I have three things, but this does look like angle side side. So what I want to check for is this HL. Do I have a right angle, which I do, and do I have the hypotenuse, which is the side opposite the right angle, which I do. So this would give me HL. So triangle BCD is congruent to GEF by HL. And then again, I have to show that this whole side is isosceles. Okay, I can also use base angles being congruent to determine if it's isosceles. So notice I don't know this whole side, I only know this little piece. So this is not going to be enough, but I do know these triangles are congruent, and I would know then these angles, these base angles would be congruent by CPCTC. So I'm going to say angle C is congruent to angle F by CPCTC. And again, if I know these base angles are congruent, that would make the whole big triangle isosceles. So this would be my last statement. So notice I'm not ending with CPCTC necessarily. So triangle ACF is isosceles. Okay, my if and then. So if a triangle has two congruent base angles, then it is isosceles. So pausing if you need to, writing anything that you need to. Okay, last one we're going to do together, number 4. So I have AE is congruent to FC. So again, I don't need to say anything else about that in my proof. FB is congruent to DE. Again, just sides being congruent, don't need to say anything else. DC being congruent to AB, don't need to say anything else. Angle AFB, so AFB, that's this angle here, and CED are congruent, that would be here. Okay, we want to prove 1 and 2 are congruent to each other. Okay, so if I'm looking at this, I see that angles 1 and 2 are in this top triangle here and this bottom triangle here. Okay, so my issue here is that I have an angle side side. That does not work. Okay, but if I knew this piece, I could do side angle side. So again, with my given statements, okay, I'm going to show. Okay, so again, I need to show top, bottom triangles are congruent. So if I had this piece here, I could say this total would be side, angle, side. So I'm going to use reflexive. Okay, and then with reflexive, which would be this piece here, I can say these two pieces added together and these two pieces added together would make my totals. So I can say AF is congruent to CE if two congruent segments, which are my smaller pieces, the AE and the CF, are added to a congruent segment, which is my reflexive. Addition, we would have sum. Then, the sums are congruent. Okay, and then from here, I would have side, angle, side. So I can say triangle AFB is congruent to triangle CED by SAS. And then if I know these two triangles are congruent, their corresponding angles would be congruent as well. So I would say angle 1 is congruent to angle 2 by CPCTC. Okay, there are practice proofs that you need to make sure that you're doing all the practice for and checking your answers on Canvas.